Today we're going to talk about complex numbers. Okay, and complex numbers are an extension of imaginary numbers. And so what we need to know about complex numbers is that complex numbers have two parts. There's a real part and there's an imaginary part. So a complex number is when we take a real number and we put it together with an imaginary number. And if you remember from yesterday, imaginary numbers are any number that has I in it. So the standard form of a complex number is A plus BI. So we have the real part here, and then we have the imaginary part here. That's the standard form of a complex number. We've got a real part and an imaginary part. And so today what we're going to do is we're going to add, subtract, multiply, and divide with complex numbers. So first, we're going to talk about solving for variables that have complex numbers in them. So if you look at this first example, we have 7x minus 2iy equals 14 plus 6i. So we have two complex numbers equal to each other, and we have two variables, x and y. These are actually very simple. What you're going to do is you're going to take the real parts of each side of the equation and make them equal. I have a 7x, which is a real part, and a 14, which is a real part. 7x is going to equal 14, and then we solve for x. Divide both sides by 7. X equals 2. Then you take the imaginary parts and you set them equal. Minus or negative 2iy equals positive 6i. So negative 2iy equals 6i. We need to get y by itself, so we divide both sides by negative 2 and I. Negative 2 and I. So the negative 2 and the I cancel, leaving me with y. And then on this side, 6 divided by negative 2 is negative 3, and the i's cancel, so y equals negative 3. Set the real parts together, set the imaginary parts together. Next example, 2x plus 3iy equals negative 8 plus 10i. Real parts, 2x, negative 8. Therefore, 2x equals negative 8. Divide by 2. X equals negative 4. Find the imaginary parts. Those are the parts that have the I. Any number that has an I is going to be an imaginary part. Positive 3iy, positive 10i. So 3iy equals 10i. We need to get y by itself, so we have to divide by 3i. The 3 and I cancel, leaving me with y. And over here, the i's cancel, but I have 10 over 3, which we were going to leave as 10 over 3 fraction. X equals negative 4, y equals 10 over 3. Since there are two variables, you should have two answers, an x and a y. You should have no i's left over in your answer because the i's should cancel when you do your division. Next, we're going to talk about adding and subtracting complex numbers. Adding and subtracting complex numbers is really no different than just adding and subtracting regular numbers. It's just like adding numbers with variables. You can only add together things that are similar. So just like a minute ago, you're going to find the real parts, negative 3 and 7, and you're going to put them together. Negative 3 plus 7 is going to be 4. Then the i's are just like x's. If you had 5x plus negative 6x, 5x plus negative 6x, you would do 5 plus negative 6 and get negative 1x. You're going to do the exact same thing with the i's. 5 plus negative 6i is going to be negative 1i. Final answer. You cannot put those together because they're not like terms. This is imaginary. This is real. So treat the I just like an x, or just like a variable. Here we have minus negative 3 minus negative 2. Negative 3 minus negative 2 is the same thing as negative 3 plus 2. So that's negative 1. And then we have negative 8i minus negative 9i. So negative 8i minus negative 9i is the same thing as negative 8i plus 9i. So negative 8 plus 9 is positive 1i. Negative 1 plus 1i. So treat the i's just like the x's and add the numbers together, or subtract the numbers together. It's pretty simple. Same exact thing for multiplying complex numbers. We look at this right here and we realize that each one has two parts. We have two binomials. So we're going to have to use FOIL, first, outer, inner, last, which we've talked about before. So we do 2 times negative 5 and get negative 10. 2 times negative 3i, which is negative 6i. I times negative 5 is negative 5i. And then I times negative 3i is going to be negative 3. And then I times I is I squared, just like x times x would be x squared. So once we do FOIL, just like we would if these were x's instead of i's, we combine like terms. Negative 10 minus 6i minus 5i is going to be negative 11i. And then 3i squared, negative 3i squared. If you remember back to your notes from yesterday, there was a part of the notes at the end yesterday where we said that I squared equals negative 1. And I said that you were going to need that information for today. This is where you need it. You have I squared right here. I squared equals negative 1. So instead of having negative 3i squared, what we have is negative 3 times negative 1. Negative 3 times negative 1 is the same thing as plus 3. So what I did here to get to here was I took negative 3i squared, I turned that into negative 3 times negative 1, which turns into plus 3. Now, if you notice, we have like terms again. I have negative 10 and positive 3, so that makes negative 7 minus 11i. Again, you cannot combine those because they're not like terms, so that's going to be your final answer there. Let's do another example. Try one more time. 6 minus 4i times 5 minus 4i. So again, we've got to use FOIL. 6 times 5, 30. 6 times negative 4i, negative 24i. Negative 4i times 5 is negative 20i. And then do the last terms. Negative 4i times negative 4i makes positive 16i squared. Negative 4 times negative 4 is positive 16i times I squared. So then combine like terms here in the middle. 30. And then we've got negative 24 minus 20, which makes negative 44i. And then again, we have 16i squared, which remember is 16 times negative 1, which makes that negative 16. Then we combine like terms. 30 minus 16 is going to be 14 minus 44i. So just remember, I squared equals negative 1. So when you see I squared, you need to be converting that to negative 1 and then changing 16 to negative 16. So we've done addition, we've done multiplying. Next, I believe, on the back of the notes, we have division. Okay, so this should look somewhat familiar to you. We've seen some problems like this before when we were doing square roots, if you remember, and we talked about the conjugate when we talked about square roots. Remember the conjugate? The conjugate is when you change the sign, but you leave the numbers the same. So the conjugate of A plus BI is going to be A minus BI, just like if we were using a radical. And so we're going to use the conjugate to simplify fractions with complex numbers. If you remember, when we had radicals, we couldn't have a radical in the denominator. And so here we don't have radicals in the denominator, but we have I. And remember, I equals the square root of negative 1. So it doesn't look like there's a radical there, but actually there is, because I stands for the square root of negative 1. So we can't have that, so we have to multiply by the conjugate. So 2 minus 3i, the conjugate is going to be 2 plus 3i. So we multiply the top and the bottom by 2 plus 3i. On the top, we have to do FOIL. 2 times 2, 4. 2 times 3i, 6i. 5i times 2, 10i. 5i times 3i. 5 times 3 is 15i squared. Then on the denominator, just like we did with radicals, you can do first times first and last times last, because those middle numbers are going to cancel just like they did last time. So we're going to do 2 times 2, which is 4, and negative 3i times positive 3i. Negative 3 times positive 3 is negative 9i squared. So now we need to combine like terms and change our I squareds into negative 1. So on the top we've got 4, 6i plus 10i is 16i. And then we have plus 15i squared. So remember, that's 15 times negative 1, or minus 15. On the bottom we've got 4 minus 9i, so that's negative 9 times negative 1, which is positive 9. So we have 4 plus 9. Now I need to combine like terms again. 4 minus 15 right here is going to give me negative 11 plus 16i. And then on the denominator, I've got 4 plus 9, which is 13. Now, if you could reduce this fraction by all three numbers, then you would go ahead and do that. If not, that's going to be your final answer. The good news about simplifying complex numbers is that you can use the calculator to do this for you. So instead of doing all of the steps we just did out by hand to divide complex numbers, we can just use the calculator. So if you look at the second example, we have 3 minus 4i divided by 2 plus I. So we're going to type that into the calculator. Now, in order to type it into the calculator, you have to make sure you're typing it in correctly, which means appropriate use of parentheses. The top part of the fraction has to be in parentheses, and the bottom part of the fraction must also be in parentheses. So I'm going to do parentheses 3 minus 4, and then if you hit second and the period button, you see an I pop up. That means I, just like we've been talking about. Close parentheses for the top of the fraction, divided by, open parentheses again, and type in the denominator, which is 2 plus I. Remember, second period is I. Close your parentheses and hit enter. Now you get decimals, 0.4 minus 2.2i. We don't want decimals, we're going to want fractions, so you're going to hit math, enter, enter to change it from a decimal into a fraction, and you get 2 minus 11i divided by 5. Now it looks a little funny on the computer screen, but that is 2 minus 11i over 5. Same thing for the third example here. We got 3 minus 2i, so parentheses 3 minus 2i. And then on the denominator we've got negative 4 plus I, so divided by negative 4 plus I using parentheses. We get a big long decimal. We don't want that. We want fractions. So math, enter, enter. Changes that to negative 14 plus 5i divided by 17. Now this doesn't only work for the division problems. We can go back and do our multiplication or addition and subtraction problems. So if we go back to our other page of our notes and we do the first multiplying example, 2 plus I times negative 5 minus 3i. So we do parentheses, 2 plus I times negative 5 minus 3i, close parentheses, negative 7 minus 11i. If you look at the answer we did when we did by hand, negative 7 minus 11i. So you can use your calculator when you're doing these problems, addition, subtraction, multiplication, and division. The calculator doesn't do you much good, however, when you're doing the solving problems because you can't get the x and the y in there. But please remember to use your calculator to help you check or work out the problems that involve multiplication, addition, subtraction, and division.